Hi, this is the fourth lesson in logarithm. In this lesson, I'm going to discuss some questions related to derivation. So this is the first question, first part. Show that log a of b squared times log b of a cube equals 6. Okay, how to find out? So the first part, I can write log a of b squared times log b of a cube. If I use the power rule, it will become 2 log a of b times 3 log b of a. Right. Now I can write log b of a by using the rule related to conversion of base. Right. I can write log b of a equal 1 over log a of b. Right. So I'm going to use that one. If I use that, 2 into 3 is 6 times log a of b times 1 over log a of b. Log a of b and log a of b will get cancelled, so that will be 6. That's the first part of this question. Okay, second part. Given that log a of b plus log b of a squared equal 3, we need to get a relationship between a and b, or I need to find b in terms of a, but a and b both are positive and a is not equal to b. Okay, so we'll try the second part. So it's given log a of b plus log b of a squared equal 3. Okay, so this I can write log a of b plus 2 times log b of a equal 3. So here you can see they are in different ways. This is a of b, this is b of a. I know that log a of b of a could be written as 1 over log a of b. So I'm going to use that relationship. So this could be written log a of b plus 2 times 1 over log a of b equal 3. Okay, so I'm going to write a quadratic equation. Based on that, I can say let log a of b equal x. Easy for substituting like that rather than keeping it as log a of b. So this I can write as x plus 2 times 1 over x equal to 3. Okay, so multiply the whole equation by x. It will become x squared plus 2 equal 3x. That's going to be x squared minus 3x plus 2 equal to 0. So we'll factorize it. It's going to be x minus 2 into x minus 1. X minus 2, you know how to factorize it. X minus 2 into x minus 1 equals 0. So x equal 2 or x equal 1. Right, so I found the value of x. That means I found the value of log a of b. That means log a of b equal 2 or log a of b equal 1. Right, now if I use the basic definition of logarithm, from this I can write b equal a squared or b equal a to the power 1, that is a. Right, but they are saying a not equal to b. So the final solution is the relationship between a and b is b equal a squared. Okay, if you want, you can try whether my relationship is correct. Substitute that b equal a squared in the given equation. If you substitute here, we'll see this is the final answer, but we'll check whether am I right. So that I can substitute and say log a of b plus log, instead of b I can write a squared of a squared, that is equal to log, instead of b write a squared here, substitute. I'm checking whether my answer is correct. So log a of b, instead of b I substitute a squared plus log d I put as pa squared of a squared. We know that log a of a squared, I can write power rule 2 log a of a plus log a squared of a squared is 1, is it? A squared of a, anything, a squared of a squared, b squared of b squared, x of x, anything is 1 plus 1. So log a of a is 1, 2 into 1 is 2 plus 1, 3. So this relationship is satisfying the given equation. This also will satisfy, but in the given question they said a is not equal to b. So I can't accept this as a solution. So this is the final solution. The relationship between b and a is b equal a squared. Okay, so this is the second question. If log c of b equal log a of c equal log b of a, show that a equal b equal c. That's simple actually. So I can write the first part, log c of b equal log a of c equal log b of a, all three are same, equal, it's given. So let it be k. Simple, I'll say let it be k. Okay, now use the definition of logarithm. If I use the definition of logarithm, I can say if I consider this and k, b equal c to the power k. If I consider this and this, log a of c equal k, so c equal a to the power k. Now b equal, if I consider this relationship, a equal b to the power k. Right. Now, by using these three relationships, what can I do? I'll multiply all these three. A to the power x plus a to the power x into b to the power x. You had that a to the power x into, b to the power x into a to the power x equal b a to the power of x. I'll use that idea. So I'll multiply all these three. If I multiply them, I'll get ABC on the left side, ABC equal, again on the right side, ABC to the power of k. Right, you can see both sides. Base is the same. Therefore, k must be equal to 1. K equal 1 means I can say b equal c to the power 1, that is c. C equal a to the power 1, that is a. A equal b to the power 1, that is b. So from these three I can say a equal b equal c, c equal a equal b. So a equal b equal c. Okay, very simple derivation. Okay, the second part looks little complicated. Students normally have confusion. How should I start, they think. Okay, no problem. You can start anyway. You can just use this relationship and start. Whatever the method you follow, most probably you will get the answer. Okay, I can show this in two different methods. Say first method I can say, method 1. Okay, so p squared equal QR. Now see the answer here. In this answer, they are saying log R of p is there. So I thought of taking, and 2 is there. You can see that there's 2 log R of p. So if I take both side log R, so I'm going to operate on both side by using log R. So that will become log R of p squared equal log R of QR. So this, I can use a power rule now. This could be written as 2 log R of p equal, if I use this one here, if I use product rule here, this could be written as log R of q plus log R of R. You know that log R of R is 1, so it's going to be log R of q plus 1. Okay. So somewhat I got this one, 2 log R of p, that part of the answer, 2 log R of p is there. So 2 log R of p is here, log R of q is there. but there is nothing called log R of Q, but 1 is there. Okay, so now I can do like this. This one to continue, I can write. So here you can see log R of P is there, but log Q of P is not here. So multiply the whole equation by using log Q of P. So that's going to be 2 log R of P times log Q of P will be equal to log R of Q times log Q of P plus log Q of P. Right, log Q of P is here, log Q of P is there. Now you can see on the right side 2 log Q of P into log R of P, 2 log Q of P into log R of P. So I got the right side part. Left side log R of P is there, but log R of P is not here, but log Q of P is there. So only thing I'm going to convert this one, but here the log R of P is there. So I'm going to convert this to base R. I'll convert this to base R, we'll see. So I can write this 2 log Q of P I'm writing first because here it's given Q of P times log R of P, same thing here, equal log R of Q is there but not in the answer. But anyway, I'll write that log R of Q times this log Q of P is there. This log of Q of P is there. Sorry, this log R of P I want. So I want to convert this to base R. So if I convert this to base R, I will get it. Log R of P over log R of Q. That's the rule related to converting the base. Say for example, log A of B, if I convert to base C, this will be written as log C of B over log C of A. I'm converting this to base C, then log C of B over log C of A. See my first lesson. There I derived it. Okay, so the link will be given in the description part. So I'm using that relationship because the left side part, this part is there already. I already got it. Log Q of P, I got it here. Log Q of P is already there on the right side, right? Plus log Q of P is already there. Only thing, I want to convert this part to R of P because R of P is given in the question, but I don't have that. Okay, so if I continue like this, you can see that now log R of Q, log R of Q, they will get cancelled. So they will get cancelled. So when they get cancelled, I will get on the right side log R of P plus log Q of P. On the left side, 2 log Q of P times log R of P. So that's the relationship. Now I can write it other way. To the left, I can put this as subject, that is log Q of P plus log R of P equal 2 times log Q of P into log R of P. See, the same thing. Okay, so method 2, I can derive this in another way. Right, so method 2 I can write by like this. So P squared equal QR. Use the definition of logarithm. Is it? Use the definition of logarithm. That is a to the power b equal x means log a of x equal b. That's the basic definition. Sorry, log a of x equal b. So use that definition of logarithm. Okay, if I use the definition of logarithm, p squared equal qr. So you know that. So this comes as base. This comes here. The index comes here. A to the power b equal x. So this I can write log p of qr equal 2. Log p of qr equal 2. Now use the product rule, right? Use the product rule. So this I can write log P of Q plus log P of R equal to. Okay, so now see, check with the answer. Now, then and there you should check the answer. What should I get that one? So here you can say 2 log Q of P times 2 log R of P. See, Q of P and R of P are coming here. How can I get this? This I can write by using the conversion, the rule related to conversion of base. I can write this log P of Q equal 1 over log Q of P, right? So I'll write this 1 over log Q of P plus 1 over log. This also I'm going to write in terms of R, 1 over log R of P equal to. Right, so take LCM, or we'll continue this one as take this as both and find the LCM. So if I write log Q of P times log R of P over log R of P plus log Q of P. Nothing, I'm using this log Q of P and log R of P as LCM. Say something like this log R of P. Q of P, sorry, Q of P, right. Okay, something like 1 over A plus 1 over B. I can take AB as an LCM, right? That will be P plus A. So same thing I did it here. Log Q of P times log R of P. So log R of P plus log of Q of P equal to 2. So I'll erase this part. Right, now cross multiply log R of P plus log Q of P equal 2 times log Q of P times log R of P. See, that's a derivation. Log Q of P, that's given here. So if you want, I can write other way. Log Q of P plus log R of P equal, right side 2 log Q of P times log R of P. So nothing to worry about derivations. If you start and if you proceed with that, you will get the answer. Okay, this is the third question. So looks a bit complicated. Yeah, they are saying alpha equal log z of A, beta equal log z of B, the base is z, and delta equal log z of C. So that's the relationship given, right? Then they ask you to show the first part. Looks complicated, equal to 0, but that's very simple, the first part. Okay, the first part, nothing actually. Don't use the logarithm, just solve this one. So alpha beta minus delta plus beta delta minus alpha plus delta into alpha minus beta equal to, multiplied inside, alpha beta minus alpha delta plus beta delta minus beta alpha plus delta alpha minus delta beta. Alpha beta, you can see that beta alpha, A, B is same as BA. So these two, alpha beta and beta alpha, will get cancelled. They'll cancel each other. Same way here, alpha delta and here delta alpha, they will get cancelled. Beta delta and delta beta, they also will get cancelled. So they all are going to get cancelled. So finally, it will be equal to 0. Okay, Okay, the second part looks bit scary. It b over c the power log z of a, c over a to the power log z of b, and a over b to the power log z of c equal 1. Okay, so how can I solve this? What's the method should I do? Now look at here, the answer and the given relationship what we derived in the first part. Now alpha, beta, delta are given in terms of logarithm, all are with the same base. Now look at here, b over c is there. Now if I substitute b minus beta minus delta by log z of b minus log z of a, say now you will get the idea that I can use quotient rule here inside. If I use the quotient rule after substituting beta and delta, I will say here beta log z of b minus log z of c could be written as log z of b over c. Here b over c is there. And alpha is log z of a. So after I solve it, after I use the quotient rule, the alpha will be the index to that one here. That alpha is coming as index. So that gives the idea. Right. So I will start from this one. Second part, alpha into beta minus delta plus beta into delta minus alpha plus delta into alpha minus beta equals 0. We already derived it in my first part. Okay, so I'll substitute the given relationships. I'm not going to substitute this one, alpha. I'll substitute later. So alpha into beta minus delta, I can write log z of b minus log z of c plus beta into log, instead of delta, log z of c minus log alpha z of a plus delta alpha, I can substitute log z of a minus beta log z of b. Correct? Not the substitution, I'm just substituting the given relationship. Okay, so I'm going to use the quotient rule here. That will be alpha into log z of b over c. I can remove this bracket now. So alpha into log z of b over c plus this one beta into log z of c minus a, c over a plus delta. So this is equal to 0 because this 0 is given there. I'm just substituting, that's all, and using the quotient rule, substituting and using the quotient rule. Okay, so this delta into log z of a over b equals 0. See, I got the relationship something. B over c there, c over a there, a over b. Yeah, you can got it. Okay, now I'm going to use the power rule. If I use power rule, that will be log z of b over c to the power alpha plus this one log z of c over a to the power beta plus log of a over b to the power delta equal 0. I use the power rule now. Right. Now I can use product rule. We know that log a plus log b equal log a of ab. Yeah, we learned that earlier. Log a of b, say log a of c equal log a of bc. Or if there are 3 log added, log a of ABC, now D equal log A of BCD, log A of BCD. You know that. So I'm going to use that product rule now. All have the same base, log Z. So this I can write log Z of B over C to the power alpha times C over A to the power beta times A over B to the power delta equal 0. Right. Now this is the log Z of B over C to the power alpha into C over A to the power beta and A over B to the power delta. So from this one, to get this one, I use the power rule. All are written with the same base. Now I'm going to use the definition of logarithm. So log z of this one equals 0 means if I continue this one, b over c to the power alpha into c over a to the power beta into a over b to the power delta equal z to the power 0. That's the definition of logarithm. Z to the power 0 means 1. That is 1. Okay, now substitute alpha as log z of a, beta log z of b, and delta log z of c. So I'll replace that one. If I replace, I'll get b over c log alpha is log z of a times c over a to the power of log z of b times a over b delta log z of c equal to 1. See, that's the question to derive b over c to the power log z of a plus c over a to the power log z of b, a over b to the power log z of c equal 1. Okay, it looks, first when we see, it looks a bit complicated, but nothing is it. We follow the proper rule, that will be, that will help to get the proper answer. Okay, I hope this lesson will be useful. Bit challenging question, but we can do that, is it? Okay, so I think it will be useful to all of you, right?